Hey, what's up, guys? This is Chung here. So today, daily challenge problem number 971, flip binary tree to match pre-order traversal. So this is like another tree problem. Basically, you're given like a tree, uh, and then you're also given like a, a voyage, basically a sequence of a desired pre-order traversal of a binary tree. And what we can do is that, we can flip a node, right? So by flipping a node, it means that we swap the left and right child. For example, we have this tree right here. And if we do a flip on node 1 here, it means that we swap the two children, which becomes to this one, right? Mm, and it asks us to find the smallest number of nodes so that the pre-order traversal of the tree matches the voyage. And we need to return the list of the values, basically the list of the nodes that we need to flip, right? In order for the tree to match this pre-order traversal. And if it's not possible, right, we simply return a -1. So some examples here, right? So for the first one, the tree is 1, 2, and the void is 2, 1. We return -1 because we can uh, there's no way we can do a pre-order traverse, you know, uh, with this 2, 1, because here, if we want to do a swap, if the okay, if the node does not have any children, then we don't there's no point to do a swap. And for this one, if we do a swap for this one, actually, so for the node 1 here, so the tree will become to this one, right? And then the pre-order traverse for this one is still 1, 2. That's why we return -1. So for the second one, this one is pretty straightforward, right? For this one, we simply need to do a swap on node 1, so we can get 1, 3, and 2, right? And then for the third one, we don't need to do anything because it's already matched, right? The pre-order traversal, okay? And then all the values are unique, right? I mean, so this one is like a little bit of variation of the pre-order traversal. So first, we have to be able to know how to do the pre-order traversal, right? So to do the pre-order traversal, we can either do a recursive uh, uh, method, or we can do a iterative method. Either way works in this case. And on top of that, right, we also need to compare, basically to compare the voyages, right? So which means that, um, so we start from the root here, right? We start from the root, and then we compare the current root, the current node with the current voyage here, and as long as it does not match, and we just simply return -1, because so what we're trying to do here is that, let's say if the one matches the voyages the first one, let's say the first one is this one, right? And then we have some like numbers after 1 here, and then we'll compare. Basically, if the current node matches, then we'll compare the next one with the one's left node. This is the left node, right? As long as this left node does not equal to this next one, then we know, okay, we have to do a swap, right? Because otherwise, we'll never get this the desired pre-order traversal. So which means that, every time when we see a difference, we'll definitely do the swap, right? Which means that we're gonna swap this left and right subtree. After swapping, we can continue to our pre-order traverse, right? So, and also after swapping, we'll add this current node to the final answer. And then we continue doing it until whenever we see a mismatch between the current node and the current index of the voyage, and then we know, okay, we find there's no way we can get the desired sequence here because we already did the swap, right? And if still does not match, then we know, okay, it doesn't really matter how we swap the node, we'll never get the desired sequence, right? So which means that we also need to maintain like the index, right, of the current voyage here. Yeah, so I think that's basically the idea here. We do a standard pre-order traversal, but on top of that, we also compare the left node, the current node's left node, with the index of the voyage. If they don't match, to each other, we swap the left node, the left child and the right child. Then we continue to do this traversal. Cool. So like I said, if we want to do a pre-order traversal, we can either do a DFS or a iterative. So I will do the iterative method here because it's more efficient. But the DFS is more straightforward. Okay, so we're gonna have like a length of the. Do we need? Probably we don't need the length here. So all we need is I equals to 0, right? Because at the beginning it's pointing to the first voyage, right? And then we have the answer gonna be the empty. And then we have stack, right? So for the iterative pre-order traversal, we use a stack, right? So current stack dot pop, I'll just finish the pre-order traversal. Basically the pre-order traversal is like this. So if current dot right, then we do a stack dot append current dot right, right? And then if the current dot left, then we do a stack dot append current dot left. So notice here, we're doing this kind of with push the right stack first, right child first, and then the left. That's how we do a iterative pre-order traverse, because we always want to process the left one first. That's why when we push those two child, we want to push the right one first and then the left one, so that when we do the pop, we always pop the left one first. And then again, right, if this current left one has another two child, we're also gonna pop this one first and then this one second, so that it will always basically the left child will always be popped first before the right child. And that's the iterative pre-order traversal. And on top of that, right, so if the current dot value, right, does not equals to the voyage dot I, right, then it means that we simply return -1, right? And if the current one equals to the voyage, and then we know, okay, we want to move the index forward, so that we can compare the next one with the left child, basically. So, and then if the current dot left, right, so if the current left is not empty, and the current dot left dot value does not equal to the voyage dot I, so right, and then we swap left and the right one, right, current dot left, and then we also add the current node to the answer, right, and then in the end I return the answer. So that's it. I mean, so here, I only compare the left one with the voyage here. So for the case, let's say if if the left one does, if the left child does not exist, I don't swap, because there's no need to swap, right? So let's say if there's a 1 here, and then there's no left child, but there's like another 2 child here. Sorry, there's another right child here. So in this case, I don't swap it, because in this case, we will simply just try to compare the right node with the void with the next void here. If they are not matched, if they don't match, right, then we simply return false, because there's nothing to be swapped in this case, right? So basically, if the left one does not match to the current one, so the only chance we can still get the desired the sequence here is by swapping the two child nodes here, right? And then after swapping those two child nodes, we continue our preorder traversal. And if the next one doesn't match, then we know, okay, means that we already tried our best. Basically, we tried to swap it, but still couldn't find the match. And then we'll simply return -1. Yeah. So if I run the code here, accept it, submit. Yep. So that's it, right? I mean, it's just like a standard pre-order traversal, and then plus a little bit of check, and then this swap here. Actually, probably we don't have to swap it. We can simply do a little bit of the tweak of the way we push into the stack, so that we will not modify the original root tree structure, because for some of the interviewers, maybe they said, okay, so can we not can you not modify the input, right? Because here we are modifying that. So for that case, what can we do here? We can simply just copy this one. We can do an if and else, right? So it means that if the left one doesn't equal if this one doesn't match, it means that we have to swap the left and right child. But if we don't swap it, what we can do is we can just reverse this the pre-order traversal, right? Which means that we can simply do a left first, right? And then we do a right next. So this is as if we are swapping the left and right child, right? And then we can just leave everything the same. And in else, we continue that. So if I run the code, accept it, yeah, still works, right? Yeah, cool. I think that's pretty much everything I want to talk about for this problem. And yeah, thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.